In this video, I'm going to look at some basic graphing calculator tips for beginners. And I'll be using Virtual TI-84 Plus Silver Edition. And this is your standard graphing calculator. And then I'll also look at compare it to the TI-89. This is a CAS calculator, which has a computer algebra system. So it'll give you symbolic answers, as we'll see in a little bit. So the first thing we'll look at is the mode. Look at your settings. So this one is set to normal. You can set it to scientific notation, engineering notation, and then you can set your decimal. You can let it float, or you can set it to up to 9 decimal places. If you're doing trig, you can set it to radian or degree. So make sure if you are doing some basic trig, you have it set to the right setting, either radian or degree, whatever you're working with. Generally, you're going to have it on function. You can have it say to parametric equations, polar equations, sequences, and so forth. And then you have other settings there: connected, dot, sequential, or I should say simultaneous there, and then real, numbers, imaginary numbers, and so forth. You can have a full screen, horizontal, and so forth. And you have a similar thing over here on this on the 89. So we go to mode here. Again, function. You can set this one is set to 6 decimal places. Set to degree. You can set it to radian, as I mentioned earlier. Exponential format, normal, real, rectangular. And then probably the most important, at least for this particular calculator, is this right here, exact approximation. So this one you can set it to auto, which is what I have it there. You can set it to exact, so it'll give you the exact answer. Or you can set it to approximate, if you want an approximate answer. We'll see how that works in a minute. Now I like to have it on auto, and then if I need an approximation to a certain problem, I can just use another feature on the main keyboard here. So I'll just close this one here. So one of the things I want to point out first, some of the symbolism here. Okay, so obviously you have a divide here. You can do regular division. So on this one here, 1 divided by 6. You have that right there. Over here, notice on this one here, if I go 1 divided by 6, because I have it set to exact, it gives me 1/6. But if I wanted a decimal approximation to this, I could hit this diamond key here, and then over here enter. Notice here, right next to entry there, we have the approximate notation there, and it gives me the same thing. Okay, so if it gives you an exact answer where you're dealing with fractions or radicals, and you want an approximation or a decimal approximation, just hit this diamond key here and hit the enter, and you'll get it. That way it's easy to get an exact answer or an approximation. Another thing that you need to know here is right here and over here. Okay, let's look at the 84 first. Here at the bottom, you see a minus in parentheses. That's for a negative number. Okay, and then over here, right above the plus, you have a subtraction. So notice if I go 2 subtract 6, get a -4. Okay. If I go, say, 2 times, and say I want to multiply by a -6, well, notice if I use this subtraction right here above the plus, go minus 6 and hit enter, gives me an error. Because that's the subtraction right here. This one's subtraction. So if I want to multiply 2 times a negative 6, use the 1 in parentheses. Negative there, 6. You get that. And you have the same sort of thing over here on the TI-89. We have the subtraction here in parentheses. That means, okay, if you're dealing with negative numbers, if you want to subtract one number from the other one, you use this one over here, the one right above the plus, and of course you have your standard division and so forth. Now let's go and look at some calculations. So we're going to perform operations here, perform the indicate operations, and simplify. So for this one, it's negative 2. So again, I select this one right here at the bottom, negative 2. And then I want to take that to the 4th power. So here's my little caret here. This to the 4th. Okay, on this one, on the 89, negative 2. Again, use a little caret to get the exponent. This to the 4th. And then I hit enter here. And notice it gives me negative 16. Over here on this one, hit enter, negative 16. So again, when you have it this way, this 4 only applies to the 2. It doesn't incorporate the negative. Okay. If you want to take negative 2 to the 4th power, then you use parentheses, like number 2 here. So put it in parentheses, negative 2, take it to the 4th power, and that's a positive 16. Same thing on this one over here, parentheses, negative 2, use the right minus sign, not the subtraction one. Take it to the 4th power, get 16. Clear this. Okay, number 3, I want 5 subtract. Now I could have the negative 9 in parentheses, so I'm actually subtracting a negative 9. So hit this sign here in parentheses, negative 9. Hit enter. So that cancels the negative here, makes it a plus 9, and a 5 is 14. And of course it's going to work the same way over here. 5 subtract, then a negative 9. Hit enter, we get 14. Okay, for number 7, or number 4 I should say, 7 times a negative 3, so I'll go 7, subtract. So notice if you make a mistake here, I'll put parentheses here, and you use the wrong negative here. So let's say, suppose I use the negative, the subtraction sign here, and put 3 here, and hit enter. Again, it gives me an error. Gotta use the right one here. So this would be 7 times parentheses, and use this one over here, the negative in parentheses, negative 3. Hit enter. Get a negative 21. Okay, same sort of thing over here on the TI-89. Now the calculator knows the order of operations. So if I let me use this one over here. Suppose I have 11 for number 5, 11, subtract 9 times 2. Okay. If you're not thinking here, you're going to say, well, 11 subtract 9 is 2, times 2 is 4. Okay. But that's not the way the order of operations works. Multiplication always takes preference over addition or subtraction. So the calculator does know. So it's going to multiply the 2 and the 9 first and then do the subtraction. So hit enter. So again, it goes 2 times 9 is 18. So that becomes 11, subtract 18. Gives me a negative 7. And of course, this one works the same way. 11, subtract 9 times 2. So the calculator is not going to make a mistake. It'll only make a mistake if you enter the values incorrectly. Don't put parentheses where you're supposed to and so forth. So clear this here. Go to the next one. Okay, let's suppose you wanted to simplify 12 over 36. Okay, on this calculator, the TI-84, I go 12 divided by 36. So it gives me a decimal. But let's suppose I want it just a reduced fraction. Well, here the numbers are small, so you can see that 12 will divide into 36 3 times. So that should reduce to 1/3. But if you just go ahead and go to math here, go to math. Number 1 is fraction, so hit enter. So basically what this is going to do is convert this decimal to a fraction. Of course I have it as a fraction, but notice when I hit enter here, it gives me back the fraction reduced. So that's what you can do when you have large numbers. Okay, for example, let me do it over here. On this one, notice if I just enter the 12, divide by 36, and hit enter, the calculator simplifies it. It doesn't convert it to a decimal. It gives you an exact answer for that representation. So in other words, it reduces it for you. This calculator will give it to you, but you have to go through more steps. Now, suppose we have larger numbers, like this one here, and you were asked to reduce this. Well, let's do this. 7, 7, 0, divide by 1, 5, 4, 7, 0. Hit enter. Okay, I get it as a decimal. But suppose I want the same fraction just reduced. So go to math, right here, and then fraction is highlighted. You can enter 1 or just hit enter. So this is saying me, okay, it's going to convert this previous answer into a fraction, which we already had, but notice it gives it to you in reduced form. So 770 divided by 15,470 reduces to 11 over 221. Notice on this calculator, if I enter 770 and divide by 15470 and hit enter, this calculator again doesn't give it to you as a decimal because it's set to exact, to an exact answer. Now if you want a decimal approximation for this fraction, then just hit this diamond right here and then hit enter, and there it is. Okay, so that's your choice. That's what happens when you have it set to exact. Obviously you have your trig functions here: cosine, sine, tangent. Okay, I won't go over those right now because this is just basic stuff. But if you're using if you're taking a trig course, obviously you're going to use those functions. This one over here also has the sine, cosine, tangent, and the inverse functions. But what you might use in basic math would be your log one. So let's look at log, at the log function here. So this is log to base 10. The 10 is not there. It's understood. So let's enter a number. Say 55. Hit enter. We get that answer right there. 1.74036, and so on. You can round it off accordingly. Now we have over here we have the natural log. ln is the natural log. That's the base e. So let me hit that key. And suppose I want the natural log of 23. Let's close the parentheses here. Hit enter. We get 3.13 and so on. You can round it off according to what they tell you. Now in this calculator over here, notice I have the ln right here, right above the x here, so I have to hit the second key to get to that function. So second ln, so let me enter the 23. And notice on this one, if I hit enter, it gives me ln of 23 because it's set to exact answers. So if you want, anytime you want a decimal approximation, if you're using the TI-89 and you have it set to exact, then just hit the diamond key right here and then enter, and there it is, 3.13549. okay, and this one is set to fewer decimal places than the TI-84, but you can change that whenever you want. Just go to mode, but you can see it gives you the same answer. Now let's suppose you want the log of 55. Okay, we don't see it here, but if I go to catalog, there it is, the first one. Okay, so hit enter and it puts it right there. So enter the 55. If I hit enter again, it gives me an exact answer in a different base. Okay, in other words, it wants to give an exact answer. So if you want a decimal approximation, just hit the diamond key here and enter, and there it is, 1.74036. Of course, it's the same thing that we got with this one. Okay, so now let's go down to the next one. Suppose I wanted to simplify this one. This is a rational expression. I've done some videos on simplifying rational expressions without the use of a calculator. Now this type of problem, what I'm going to do here on the TI-89, you won't be able to do it on the TI-84 or other versions of the TI-89, the TI-80, or the TI graphing calculator, unless it's a CAS calculator that has a computer algebra system built in. So notice what happens if I type in this expression. So I'm going to go parentheses, and then I have x squared plus x minus 2. Close parentheses. So I got x squared plus x minus 2, and I'm going to divide it by, okay, again, important to have parentheses here. So x to the second plus 2x minus 3. So notice this does the same sort of thing as with the ones with numbers, like number 7. Notice if I hit enter, it's telling me that x squared plus x minus 2 over x squared plus 2x minus 3 reduces to x plus 2 over x plus 3. Now normally, if you're going to do this without the calculator, you'd have to factor the numerator, factor the denominator, and then cancel out like factors, and this is what it comes out to, x plus 2 over x plus 3. Can't do that on the TI-84 or the TI-83. Has to be a CAS calculator. It has to have a computer algebra system built in. Okay, we're going to look at something again that you can do on this particular calculator. Now on the TI-84, you can work some of these problems out, but you'll have to use graphing, which takes a little bit longer. So I'm going to focus on the TI-89 here. So let's suppose I wanted to solve this linear equation. very easy to do. Hit the F2 key here. And notice the first one has solve. So hit 1, or just hit enter since it's already highlighted. Either way. And then just enter the equation the way you see it there. So it's 2x minus 1 is equal to 5x minus 6. And then put a comma. And then you have to indicate the variable. We're using x here, so put an x. And then close parentheses. And then hit enter. And the calculator solves it. The value of x that will work for this equation is x is equal to 5/3. In other words, if you replace the x by 5/3 on both sides of that equation, you'll get the same number, which tells you that x equal to 5/3 is a solution. Okay, the next one is a quadratic. Now these types of equations will have at most two solutions. They could be real solutions. They could be imaginary solutions. So let's go ahead again and use these are the same command here. Number 1, so hit enter. So let's just enter the equation the way it is. X squared, the caret to get the exponent, and then 2. And then a minus x minus 12 equal to 0. Okay, now we need a comma, indicate the variable, so just put an x there, and close parentheses. And usually a quadratic, we expect two solutions at most. It could be repeated solutions. Let's see what we get here. Hit enter. And of course, I got the answer, but I typed in the equation incorrectly. The right side should be 0. So let me go back to this one. That is the solution for this one. Notice it has radicals. But this one here, the right side should be 0. So I just come back here and then hit this arrow right here to eliminate the 1 and then put in a 0. And then hit enter. And now I get the real solution for the one I was trying to work, x equal to 4 or x equal to negative 3. And you can see it checks. If you put a 4 where the x is, 4 squared is 16, and then minus a 4 is 12. Minus 12 gives me 0. You put a negative 3 there. Negative 3 squared is 9. Minus a negative 3 is 3. 9 and 3 is 12. And then the minus 12 gives me 0. So that one checks out. Now, the next one is a system of equations. 2x minus y equals to 4. 3x plus 7y is equal to negative 11. This is a system. They represent lines. So on the 84, I could get the solution to this one, but I would have to graph. Or I would have to use matrices. So I can work this out on the TI-84 several ways. But first I'm going to do it on the 89. So on the 89, again, I'm going to go to solve, F2, and I want the solve. Before I go to the next one, though, I want to point out that there's some cases where you're solving a quadratic and your answer might have imaginary solutions. So when you use this command here, it's going to give you a false statement. It'll say false because it doesn't have real solutions. But there's such thing as imaginary solutions. So in that case, you would want to use right here on complex. This one here. Notice it's the same command except it has a C in front of it. Notice C solve. So that means if your equation has imaginary solutions, this will give it to you. So if you're not sure, you can always use this command and it's still going to work. Okay. But again, we're going through the basics here, so I'm going to clear this. Now, getting back to this over here, F2, I'm going to solve a system. So this one will allow me to do that. So hit 1, so just hit enter. So I'm going to enter this equation right here the way it is. So it's 2x minus y equals to 4. Okay, now what I need, I have to enter the other equation, but I have to put an AND right here for this to work. So here's the way we do it. We go to the math menu, so that's number 5. You can see it there in the background there. Math. So hit second, and then 5, and then we're accessing the math menu. Number 8 is test, so just hit 8. I want to go to test, so 8. And notice number 8 here again in this menu is AND, so hit 8 again. It puts the word AND right there. Now all I have to do is type the second equation the way it is. So 3x plus 7y is equal to negative 11. So hit the negative sign. Okay, and then just unlike the other type with one variable, put a comma. But see, on the other ones we saw it was only one variable x. This one has x and y, so we have to indicate both variables. So what we do is we have to use braces right here, right under above the parentheses here. So I need the second key. So second, and then hit this right here, parentheses, and notice I had a brace there. Instead of parentheses, I get a brace. So enter x, and then a comma. Now I have to indicate the y. So type in a y, and then close the braces. Okay, so that'll be the right side of this one. So second, and then right here, right above this parentheses, we're accessing that right brace. Close parentheses. Hit enter. So this tells me that x equal 1, y equal negative 2. That's the ordered pair. 1 comma negative 2. Notice it works. If I put a 1 where the x is, that'll give me a 2 there. A negative 2 minus my negative 2 is a 2, so 2 and 2 is 4. Checks. Put a 1 over here in the second equation. 1 times 3 is 3. Negative 2 here where the y is times 7 is negative 14. 3 and negative 14 is negative 11. It checks. Clear this. And the only thing I wanted to show here, just the basic stuff here, is the graphs. So let's go to y equals, another calculator, y equals, and now here I'm going to show you another way to work this system here on the TI-84. So what I've entered is, these are lines. Okay, these are lines. So all I did to get the first equation for the first function here is I solved the first equation for y. So I brought the y to this side, the 4 over. So y is equal to 2x minus 4. Put the y this way, and then I just switch the sides. No problem. And then on the second one, I brought the 3x over to the other side, made it a minus 3x minus 11, and then I divided both sides by 7. That's how I got this one here. So if you're dealing with systems of equations, linear equations, those are lines. So if the lines intersect at one point, you have one ordered pair or one solution. If the lines are parallel, there's no solution. Or there could be an infinite solution if they coincide. So let's do this. Let's graph here. Hit the graph. And there we have it. So let's see. We got, for this one, we got 1 and negative 2 for the answer. So there's, you can see where the lines intersect. So sometimes you can do it by inspection. So no, okay, I'll go 1 over. It looks like I go 2 down, so it should be 1, -2. Now it could be that the intersection involves decimals or fractions in decimal form. So another way we can do it besides inspection is go to second and then trace. I'm accessing the calculate menu. So which command do I use? I want to know where the lines intersect, so that's number 5, so hit 5. Okay, so this one says first curve. So I want to put this cursor, move the cursor to the first curve. Okay, so close to where they intersect. And then hit enter. Now for the second curve. So now I want to go to the second curve next to that point and hit enter. Now I want to guess. You can ignore that and just hit enter. And it says intersection occurs at x equal 1 and y equal -2. And obviously we check that, but you can check that to make sure it works. Okay, so those are just some basic techniques that you can use on the TI-84 or 83. Similar other brands of calculators will have the same features. Of course, the 89 again is special, or calculators like the 89 which have the computer algebra system are special because you can get symbolic answers. It'll solve equations, systems of equations, it'll factor, it'll reduce a rational expression. So that'll be it for this video. If you have any suggestions or you want to see a little bit more of some of these ideas, please leave a comment below. Thanks for watching. We'll see you next time.